Hey guys, let's take a look at quotient rule. So remember, quotient is the answer to a division problem. So if you have some sort of function with division in it, a fraction in it, you're going to have to use the quotient rule. So if you have a quotient of u over v, the derivative of that quotient is going to be the derivative of u times v minus u times the derivative of v all over v squared. Now that's hard to remember, so we have a little rhyme that every calculus teacher I know uses. Low d high minus high d low all over low low. So let's take a look at this first one. So what I'm going to do first is figure out what my derivatives are. So the derivative of the top, that x squared plus 1, the derivative of that is going to be 2x. Then on the bottom, the derivative of 2x minus 5 is just 2. These are my derivatives. Okay, so now we want to go ahead and find our actual derivative of this whole function. Low d high means take the function on the bottom, low, 2x minus 5, times the derivative of the top. So we'll multiply that by 2x. Then we have a minus. High d low. High is before we take the derivative, so that's still going to be x squared plus 1 times low, or d low. Derivative of the low, we decided that was 2. And then that's going to go all over low, low. So that means my bottom squared. Boom, all done. Okay, on this next one, let's find the derivative of the top and the bottom first. So 5x plus 3, the derivative of that is going to be 5. For x cubed plus 1, the derivative of that is going to be 3x squared. I hope you have A written down because I need to erase it so I have enough room for B. Cool. So we're taking the derivative of y with respect to x, so dy dx equals low d high. So low means my function down at the bottom, x cubed plus 1, times the derivative of the top, d high. So I'm multiplying that by 5, minus high d low. So high was 5x plus 3, times d low. So the derivative of the low, we decided that was 3x squared. And then it's going to go all over low, low, so my original denominator squared. Okay, let's take a look at another one. So we want to find the derivatives of both the top and the bottom. I think it's helpful to do that. So the derivative of x plus 2 is just 1. The derivative of e to the x minus 3 is e to the x. So we'll find the derivative f prime of x equals low d high minus high d low all over low low. So low, e to the x minus 3, d high, the derivative of the top was 1, minus high, which was x plus 2, d low, so the derivative of the bottom was e to the x, all over low low, or e to the x squared. If you wanted to fix that up, you could. E to the x minus 3 minus e to the x, x minus 2 e to the x. Oopsies, all over x squared, or e to the x to the 2x. Oops, my face got in the way. There we go. There's all the simplification done. Okay. Now here's another one. We want to find the derivative of the tangent of x. So one thing that we're going to have to do first of all is think about how could we rewrite tangent in a way that's helpful to us. Now remember, this is the quotient identity. How can we write tangent in terms of things that we already know the derivatives of and written in a quotient? Yeah, tangent is sine over cosine. So we're going to go ahead and find the derivative of sine over cosine. That's the plan. I'm going to go ahead and erase C, so that way I have enough room. Cool. There we go. So, first we're going to find the derivatives of the top and the bottom. The derivative of sine is cosine. The derivative of, cosine is the opposite of sine. So we're taking the derivative of y with respect to x, dy dx. Low d high. So my low was that cosine of x times the derivative of the top, or d high, times cosine x, minus high d low, so the high was sine, times the derivative of the bottom, negative sine, all over low low, or cosine, squared. Now when we start to clean this up, cosine times cosine is cosine squared. Negative sine times negative sine is positive sine squared over cosine squared. Hopefully from last year in our verifying identities unit, you remember that cosine squared plus sine squared is equal to 1. And that is in your formula notebook. And remember, the reciprocal of cosine is secant. So 1 over cosine squared is the same thing as secant squared. So the derivative of tangent is secant squared. Okay, let's look at E. So we have sine squared over x cubed. So first, let's talk about finding the derivative of both the top and the bottom. So what might be helpful, in fact, let me do this work down here. So we're finding the derivative of sine squared, right? Let's also talk about finding the derivative of sine squared. It might be helpful to think of that as sine of x squared, because we're going to have to use the chain rule here. Remember that 2 is going to come out front. We'll subtract 1 from the power, so now it's to the first, which is why I don't have anything written. And then we're going to multiply by the derivative of the inside. The derivative of sine is cosine. So sine squared x, his derivative, is going to be 2 sine cosine. And then for x cubed, his derivative is 3x squared. Okay, so let's go ahead and find this derivative. G prime of x equals low so x cubed. D high, so the derivative of the top, 2 sine x cosine x, minus high d low, so my original high was sine squared x, times the derivative of the bottom, 3x squared, all over low, low, so we're going to take that x cubed and square it. Now you don't have to, but we can clean this up a little bit. End up with 2x cubed sine squared cosine, oopsies, not sine squared, my bad, sine x cosine x minus 3x squared sine squared all over x to the 6th. All right, good deal. There's f. Ooh, okay, we're going to put f a little bit farther down. This was 2y equals 2x to the 4th minus 4x all over cosine of x. So, we'll look at these derivatives. The derivative of the top, let's see, we'll bring that 4 down and multiply, so that's 8x, subtract 1 is 3. Then the derivative of negative 4x is negative 4. There on the bottom, the derivative of cosine is the opposite of sine. So, let's find this derivative. Derivative of y with respect to x equals low cosine of x, d high, so multiplied by the derivative of the top, 8x cubed minus 4, minus high d low, so the original high, 2x to the 4th minus 4x. D low is the derivative of the bottom times negative sine x, all over the bottom, which is cosine x squared. Now there's really no nice way to clean this up. I'm going to go ahead and put what I would put as my final answer. Cosine of x times 8x cubed minus 4. Negative times a negative makes that a positive. I'm going to put that sine x out front times that 2x to the 4th minus 4x all over. And then cosine squared just tends to be written like that more often. All right, good deal. See you guys later.